Hello everybody. Now we have talked about zero error and the error of magnetic compass. Now let us see what happens to the magnetic compass once it is placed on board the ship. We know that a freely suspended magnetic needle under the influence of Earth's magnetic field alone points towards magnetic north, and such a magnetic needle is called magnetic compass. Now if the same magnetic compass is placed within some other magnetic field and a changing magnetic field as such, then this compass will be influenced by more than the Earth magnetic field. It will be influenced by two or more magnetic fields. Then such a compass would not be pointing towards magnetic north. It would deviate from the magnetic north. And ship, as we know, that is made up of iron and steel, so it will have its own magnetic properties and which keep on changing with the motion, with electrical equipments being played around here and there. So once this magnetic compass is placed on board, it is under the influence of more than Earth's magnetic field alone. And such a compass would not be pointing towards magnetic north. And once this magnetic compass is placed on board, we refer to it as just compass. Now, no more. We do not use the word magnetic anymore. Just call it compass. Differentiate it between magnetic and compass once it's been placed on board. The direction indicated by the compass on board is called compass course or compass bearing. Freely suspended would be pointing towards magnetic north, and a magnetic compass which is influenced by plus, as I said, would be pointing towards compass north. It will deviate from the magnetic north. The angle between magnetic north and compass north is called deviation. Variation we talked about is changes with position, and you can get the value of variation on the, it is given on the charts on the compass rose along with the yearly changes. The deviation can be obtained from a card bridge called deviation card, which is lying on the bridge. Deviation, like variation, can be east or west depending upon its position of compass north in relation to magnetic north. If it is east of the magnetic north, we call it deviation east. If it is west of the magnetic north, we call it deviation west. Now, the angle between true and magnetic north, we have come to know that it's called variation. Now, if this line what I have drawn is the course of a ship and being read off magnetic compass, it is reading something like 065. So our magnetic course would be 065. And this magnetic course I'm talking about is a freely suspended magnetic needle. Now, compass once it is magnetic compass when it is placed on board is called compass. And now if this course was read off the compass which is on board, read something like 040. It is pointing towards compass north. So the angle between magnetic north and compass north, which is the difference between these two readings also, 20 degrees, is called the deviation. You can see here, compass north is pointing like this, true north is pointing here, magnetic north was pointing here. The difference between these two is about 25 degrees. The deviation is said to be east if compass north is to the east of magnetic north. And if I had these two values, I will not be drawing all this. I will be just calling it compass least. Error is east. Deviation is east. So compass least, error east, I found out. So 25 degrees is the deviation, which is easterly. It is called west if compass north is to the west of magnetic north. And as I said, I would go about by looking here. Compass west, error west. So deviation would be 27 degrees west. And as you can see here, if I had to convert compass to magnetic or magnetic to compass, I would have to apply deviation. Now from true to magnetic is variation. It's not the other way around. Always true to magnetic is variation. And magnetic to compass is deviation. That's why I made the arrows like this. The true course you can see is 0.65. If this course was being read by the magnetic compass here, which is pointing towards magnetic north, getting a value of 0.45, that's my magnetic course. Between true and magnetic, variation. And as I said, compass least, error east, compass west, error west. So compass is less, so variation would be east 20 degrees. Now if the same course was being read by the compass once it is placed on our ship, referred to as only compass, I can see that the compass course is about 25. The angle between the magnetic and the compass is the deviation. Magnetic and the compass is deviation, which you can see here. Magnetic north is pointing here, compass north is pointing here. The difference is about 20 degrees, which is reflected in these values here of magnetic and compass. And I would go by east, least. The compass is least, so deviation should be east. The deviation is 20 degrees east. As I said, on the out at sea, we do not have anything like magnetic north pointing, compass pointing towards magnetic north. It is pointing towards compass north. So we will have only either true or the compass. And the difference between these two, the difference between the north, true north, and the compass north is called the compass error. And again, same compass least, error east, compass is least, error is east, 40 degrees east. So when we found out that variation was 20 degrees east and deviation was 20 degrees east. We can see that the compass error is the sum total of variation and deviation. So variation was 20 degrees east, what we found out, and the deviation was again 20 degrees east plus. So compass error is variation plus deviation. So here I have written down the word algebraic sum, plus minus. In this case it is both plus. So when you have got variation and deviation, same name, you add it up, and that is your compass error. Now I'm just trying to show you if the errors change here. True course 65, magnetic course 0.45. Variation is between true and magnetic. The difference is 20 degrees, what you can see here. Being east of true, it will be easterly. I'll hold on to compass least, error east. So my variation would be easterly 20 degrees. If the same thing was being read by compass, now the compass north is to the west of magnetic north. And the reading is 0.85 here. The angle between magnetic and compass is called deviation. And the deviation would be westerly because its compass north is to the west. And the value is, you can see, 40 degrees here. Here also, variation would be, deviation would be 40 degrees west. I still hold on to the same of compass west, error west, deviation 40 degrees west. As I said, out at sea, we do not have anything like magnetic north here. We'll only have true and the compass. And the difference between true and the compass is called the compass error. And compass is to the west, so the compass error would be west 20 degrees. So compass west, error west. So compass error is westerly 20 degrees. And if you remember, we calculated our variation as 20 degrees east and deviation as 40 degrees west. And you can see that the compass error is deviation minus variation. So deviation between magnetic north, compass north 40 degrees minus variation. So compass error, as I told you earlier, was the algebraic sum plus minus. Now in this case, when you have got variation and deviation opposite names, you subtract and retain the name of the higher value. Now, one of the jobs of a navigator out at sea is to be calculating the compass error, which he does by calculating azimuth. Azimuth, which I told you earlier, was the bearings of the heavenly bodies, and that is what we'll have out at sea to work on. How does he go about calculating azimuth would be a topic of discussion a bit later. Let us say that he has calculated the value of can be a star, can be sun, moon, or whatever it is. That's 58 degrees true. Normally, he would take the bearing also of the object what he has calculated with the gyro, and let us say that his values what he observed was 0.56. So true, we can find out what is the gyro error. True is 58, gyro is 56. That means gyro is reading 2 degrees lower. So gyro error is 2 degrees low. Now at the same time, what the mariner does, he checks up with his compass, which is there on his monkey island. So let us say that he was steering a course of 120 and the reading of gyro is 120. Knowing the value of the error, we know what is the true. So when he saw that the gyro was reading 120, he read the compass also, and compass is reading 140. Knowing the value of gyro compass, error of gyro compass, I can always get the true. And my true is 122. Compass was 140. So I can get my compass error. Compass least, error east, compass best, error west. So the compass error is 18 degrees west. Once I have found out my compass error, I can always check up for my variation from the chart, which I said is there on a chart. and get the deviation and can be compared with the deviation card on board. Compass error is algebraic sum plus minus. Between true and magnetic is variation. Between magnetic and compass is deviation. So if they have the same names, you add it up, different names, you subtract and retain the value of name of the higher value. There's a few questions what I have just tried to explain the things to you here. And I'm sticking to the same rule of mine is compass least error is compass best error best. Here he has given me variation, deviation and true course. I can find out magnetic with error is east, compass would be least. Here west, compass would be best. But now that I've got variation and deviation, I'm finding out the compass error straight away here. And being different names, I'll subtract and retain the value name of the higher one, which is east, 2 degrees east. So I've got my compass error 2 degrees east. So compass should be least. So compass would be 0.95. And then I can always find out magnetic either from here or here. Works out to the same thing. It is compass is best here. So this should be less. And compass is least here. So compass will be least by 5 degrees. And compass is best by 3 degrees. So 0.92. So now this, I'm just trying to show you how the mariner compares his compasses at this particular time. He took the bearing as 0.95 true and then calculated the error as 2 degrees low. So once he has calculated the error and his course was 0.95 and error was this. So now he knows that my true should be is reading lower 0.97. When he has seen that my true course is 0.97, he'll get the value of compass course. And the angle between these two is your compass error. And compass is least, error is east. So error will be 2 degrees east. And then he can follow, get the value of variation from the chart and do the needful for finding out the variation, deviation. Similarly here, the next question here, given me variation and deviation, I can always find out my error. Once I know my error, I can find out. Here I can find out using, I have the magnetic, compass should be best. And here also west, compass should be best. So compass is best. The compass should be best here. 13 degrees, it will be less by 13 degrees, 151. Now here he has given me true, magnetic and compass. I can find out my compass error. Compass best, error west. Here, compass best, error west. Compass best, error west. Now you can see variation plus deviation is 9 degrees west. So again a question of just comparing compasses. Let's say gyro error 2 degrees high. So your true should be 273. You read the compass at that particular time. Compass is reading 282. So compass is best. Error will be west. And then you can do the needful to find out variation from the chart and deviation and get the values. Now this next question here, he has given me compass course. He's given me variation, deviation. I can always find out my error. Different names, subtract, higher value, west, 2 degrees west. The compass is west, error is west, so true will be less by 1 degree, 167. And similarly here, compass is west, that's why error is west, 174. Here, he has given me the deviation, he has given me true and magnetic. I can always find out my variation difference between these two. Compass is least, error is east, 5 degrees east. Here it is given to me 5 degrees west, so compass should be west here. So 343, compass error plus minus, different name minus nil. So this is how you go about finding out your compass error and applying your compass error to get the true course or bearings. So here the last one for just comparing compasses, that you have got gyro reading 345. You had an error of 2 degrees high. So gyro is reading higher than the true 343. If at the same time you read your compass 343, error is nil. And then you can go ahead and find out the rest of the things. Now that we have finished up with the what is positions, how to go about measuring our distances, what are the courses with directions. Now the problem starts off with finding out the course and distances from our departure to our destination. Now this we will be dealing in different type of sailings. First of the one of them I'll be talking to you about parallel sailing, in which you sail along either your meridian or your parallel of latitude, in which we'll be talking about delat and departure. Then we'll talk about plain sailing, in which you sail across the two places obliquely, in which we'll be talking about again delat, departure, distances. And finally, we'll talk about Mercator sailing, in which we use different terms like DMP, that's your difference in meridional paths, and D-long. And you make some triangles like this. And then we'll be comparing two triangles, what you can see here, to get to find out our two courses, distances. So we are all set to start off with all this. So I will continue with the uh, sailings next. Till then, take care. I'll meet you with parallel sailing.